Yes. So let us now discuss the physical properties of alkenes. Okay, so when we say physical properties of any compound, we are mainly talking about the nature, the size, the density, pressure related stuffs. Okay, what is the vapor pressure, vapor density, and things like that. Polarity, shape. Okay, so these are the things, and of course, we also talk about their boiling points, the melting points, the vapor pressures. All these all these parameters contribute to the physical properties of any compounds in general. Not talking just about alkenes. Okay, now specific to alkenes, all the alkenes, they possess weak van der Waals forces. Okay, weak van der Waals forces. You know what are van der Waals forces? So there is a weak force between the various atoms of alkenes, and uh, all the alkenes, right from the lowest methane all the way up to higher number of carbons, they all have weak van der Waals forces. Now, let us talk about the state. If there is only one or at the most four, like that is from methane to butane, they exist in the gaseous form. Okay, the atoms which are the molecules which are very light, okay, containing only one carbon or max up to four carbon, that is from methane to butane, they exist as gases. C5 to C17, they exist as liquids. Okay, so that is from pentane all the way up to alkenes having C17 carbon atoms, and greater than that they will be in the solid form. Okay, next, they are colorless. All the alkenes are colorless and odorless. Okay, they are insoluble in water. Why? Because they are non-polar in nature. Insoluble in water, I have to mention this. Okay, insoluble in water. The reason is because they are non-polar. Okay, they are non-polar. You know about polarity. If you talk about any alkenes, the electronegativity difference between carbon and hydrogen is negligible. So that's the reason we do not, all the alkenes or all the hydrocarbons for that matter, they are non-polar. Okay, so because they are non-polar, they become insoluble in water, but they will be soluble in any other organic solvents. Like if you take benzene, kerosene, all these are soluble. Alright. Now, next, petrol, what is used as a fuel, is a mixture of hydrocarbons, various hydrocarbons. It is also used in dry cleaning. The reason why we use all this petrol or diesel in dry cleaning is because the grease which cannot be washed using water, because water is a polar solvent and this grease is non-polar in nature. Alright, so this grease is basically a mix of some higher alkanes. The grease stains, they cannot be washed away just by using water. So that's the reason you cannot use water if you want to clean stains which are made up of grease. So you need to have something which can clean away all these grease things. And what are those? We can use petrol or diesel. The reason is this is also polar. The petrol or kerosene, they are also polar. Like dissolves likes similar ones, right? So that's why this is the reason, because a polar compound is soluble only in a polar solute is only soluble in a polar solvent. Non-polar solute is soluble in a non-polar solvent. This is non-polar solute. It will be soluble only in the non-polar solvent like petrol. Okay, and the most important point here is about boiling point. Boiling point, in very important, they'll ask you questions based on arranging in the ascending and descending orders of boiling point. So yes, so boiling point increases with increase in the mass. Okay, As mass increases, as the weight of the atom increases, molecular mass I'm talking about, it increases. Also, the reason why is because, also let me write, that is because boiling point increases because, yes, I have to write this, because van der Waals forces increase with mass and area. If you understand this much, I think pretty much you will be able to arrange things in the increasing order. Okay, so boiling point increases with mass. The reason is because as and when the molecular mass, like you're starting from methane, if you go to ethane, then propane, then butane, what is happening to the mass? It's becoming heavier. You know there is a mass difference of 14 AMU between successive members in case of a homologous series, and I can say all alkanes are homologous series. So the weight steadily increases as in when you start from a lower alkane to a higher alkane. So you can see that mass increases. The reason mass increases and their boiling point also increases. So methane has a lesser boiling point as compared to ethane and as compared to propane and all that. The reason is also important. Van der Waals forces increases. More the mass, more is the van der Waals force. And that's the reason more is the force. What happens? How is it linked to boiling point? If you, what is boiling point? The temperature at which the liquid changes into liquid, vapor or gaseous state, I should say. In that case, you need to overcome these forces. If the molecules needs to be separated from liquid to a gaseous state, you need to actually, overcome the force of attraction which holds them as a liquid. Correct? So, if there are more van der Waals force, that means there is more force. You need to heat it more. That means the boiling point increases. Okay? Very simple logic. Area also it increases. The more spread out it is, the more is the van der Waals force, and more will be the boiling point. If it is more condensed, the area is less, it's becoming condensed, area is less, van der Waals forces are less, boiling point will decrease in that case. Okay, let us take some examples. This point is very, very important. Only two things you need to remember. If there is increase in mass, more is the boiling point. Why? More is the van der Waals force. Increase in area, more is the boiling point because more is the van der Waals force. Yes. Let us take an example. If you are talking about methane, methane has a boiling point of about, mass of it is 16, you know this. Boiling point is 1, 1. You don't have to remember this name, I'm just telling you. Next you have ethane, whose molecular mass is 30 AMU and its boiling point you can see is 184. Okay, and then you have propane, C3, H8, its molecular mass is 44 and it has a boiling point of 230.9. So you see, as the mass increases, you can see that boiling point also increases. Okay, so if they ask you, if you feel that masses are different, obviously whichever has least mass will be having the highest, lowest boiling point, and it increases with the mass. Now, let us consider this. I have pentane, and you know that there are different isomers for pentane. What is the molecular formula? C5H2. This is pentane, and its molecular mass is 72U. 12 plus 60 plus 12, 72, right? So now, what are the different isomers? One is your straight chain. I'm not going to fill it. Okay, so this is N-pentane. And then you have isopentane. Okay, this is your isopentane. And then you have your neopentane. Okay, this is your neopentane. This is isopentane. This is neopentane. And you know the IUPAC names. Okay, now all of them have the same mass because they are all having the same molecular formula. How will I know, or does it mean that they have the same boiling point? No. First is the mass. More priority is with the mass. If masses are same, then area comes into picture. This is having more area. Area is greater here. Area is a little less here. Area is the least here. Why? Because it's more packed. If it's more spread out, it's covering more area. Now here it is more packed. It is condensed. Okay, so area is less. So which one will have a highest boiling point? This will have a highest boiling point, about 309. This will have around 308. And this will have around 282. So now you can understand how to arrange a series of compounds in terms of their boiling point, either in the ascending or descending order. If you think masses are different, then go the element or the compound with the least mass will have the lowest boiling point, and it increases with the mass. If you think that masses are same, and you can actually, okay, I have not written pentane. Pentane will come somewhere here. Now you see it's 230, with butane it is somewhere, and pentane it is somewhere. Okay, now if you talk about hexane, obviously you don't have to worry about it. If they give you all this and then hexane also, hexane has more number of carbons, so obviously it will be more than all of this. Okay, so that's the thing. Okay, so first sort it in terms of mass, and if you think the mass is same for any two compounds, then you will have to decide based on the area. Okay, whichever is linear has more area, more is the van der Waals force, more is the boiling point. More condensed, least is the area, less is the force, less is the boiling point. Okay, yes.